Okay, I believe I should be live. Yeah, so got a couple minutes before we actually get started. I might wait till like 6:32 or something to actually start the presentation. So hang tight, jump in the chat. We can, after the presentation, I'll be taking questions about the thing that we're going to be talking about. So yeah, feel free to talk there, or if you're in the React Denver Discord, that would work as well. Jeff, can I get a signal as to whether or not this is working? Nice. How's the audio? Thank you, Jupiter. Cool, so it's video is a bit choppy. Honestly, it might be on my end. I feel like, yeah, I'm usually streaming in like some ridiculous quality, and I don't actually know if my bandwidth can actually support it. What is a React Denver Discord? This is my first time here. So yeah, so basically what's happening is that this talk was going to be hosted by React Denver, which is like an awesome group of people that host React focused talks. I want to say monthly. And unfortunately there were some just technical issues, so we fell back to using my Twitch stream for it. But yeah, so React Denver, they have a Discord. I want to say it's React. Let's see. I'm just going to Google it. Yeah, reactdenver.com is the website, and they're on Meetup. Oh no, video's choppy. What can we do about that? Let me see. Nice, thanks Jeff for dropping that. I know, I mean, I'll be honest, I'm kind of a noob when it comes to streaming, and I'm using OBS, which has a lot of settings that I don't actually understand. I don't actually know if I can lower my bitrate while I'm live. But let's try it. Might that be better? And actually, why don't I just start, I'll start sharing my screen. Maybe that'll actually make for a better experience. Cool. So yeah, if you're not aware, the topic that we're going to be talking about is, yeah, no, I should definitely be streaming in 30 FPS. What am I doing 60? We definitely don't need to prioritize quality, or I guess fidelity, I'm not sure. But yeah, so I'll get started in just a minute, but for anybody who is not aware, this talk is Illusory Children for Cleaner Component APIs, and it's going to focus specifically on a thing you can do in React to design some component APIs that might be better than some alternatives, and it leans pretty heavy into some just like more the internals of React and the things that like, actually make up React elements and that sort of thing in order to accomplish this pattern. So I'll get started. Let's do a hard start at 6:35 Mountain Time. So just 2 more minutes. As soon as it hits the 5-minute mark, I'll just jump right in. And sorry everybody, but just trying to give people a couple minutes to actually join and find the new link and everything. Cool. So 1 minute. I know. Sorry for the bad video. I don't think it's just your end because a couple folks have said that, but yeah, I feel like we'll just have to live with it for now. Hopefully, since it's mostly static content, it won't really affect the quality much. Cool. Oh man, except now I lost. Let's see. Yeah, so I'm in the meetup right now. I'm trying to, oh man, how do I find this, the window that I just dismissed? Perfect. Okay, we're gonna get started. So yeah, thanks everybody for joining me for this talk. So again, the title of this talk is Illusory Children for Cleaner Component APIs, and it's going to focus on a specific pattern that you can implement in your React components to sometimes like simplify how they're actually used. And hopefully we can come away from this understanding a little bit of the more infrequently used things that React makes available. So I'll get started by introducing myself. So I'm Dan Cortes. I'm currently a front-end developer at Coinbase. I've been building software for about 10 years, working with React for 6 years. If you want to come say hi, I'm usually in the Denver Devs Discord, as well as the React Denver Discord. And here you can find me on GitHub, Twitter, or LinkedIn. I'll be posting the slides for this presentation in the meetup in the React Denver page for this event. And all these links will be clickable. So this slide will probably make a little bit more sense. So yeah, let's just dive in. So what do we mean by illusory components? So the definition of illusory is based on or producing illusion or deceptive, which I hope that you guys will agree that this is, because what we'll actually be seeing and how it works under the hood are very, I don't think one would infer how it's actually implemented. And let's actually begin by looking at an example here. So on the right here, we have this demo component that's using this table. The table component, it seems to take some data. And up at the top, you can see that the data type that this data is an array of objects with an ID, first name, last name, email, and profile pic. Cool, so the data wrapper takes this array of data. And then inside the table component, we have some columns. It's like common table stuff. The columns have a heading, which is a string. And then they have a render prop, which it looks like that returns the actual content for each of the cells on this table. So, pretty simple, easy to use component. You feed it data, you define some columns and some render props, and then it generates a table for you. Personally, I think this is a better API than the actual like HTML table API with like T heads, THs, T bodies, TRs, TDs, all that stuff. This is a little bit more straightforward, and one can think of this as an abstraction over the actual way to render a table. So again, this takes this table component implements the compound component pattern, since column is a child or a property on table, and they're kind of used together. And ultimately, we can assume that this is going to render a table for us. Awesome. So let's look at how this is actually implemented. So we see here that the table, so we can pretend that the table component has like a bunch of implementation details. But the column itself, the column that we were feeding heading and render, is actually, and we'll actually like dive into the code later, but for this, it's actually this component that returns null. And what's kind of weird about this is that this component is actually taking props. So, it expects props in the shape of column props. So heading must be a string and render must be a function that can take an item and return a React node. But the column component isn't actually doing anything. And this is what I mean by like illusory. Like this component, it looks like it's doing something, but it's really doing something else. So what's going on? So before we actually dive into how this works, let's talk about React elements a little bit. So yeah, let's deconstruct them. So as you may know, JSX is just syntactic sugar. There's nothing special about the bracket syntax. We are ultimately just compiling things down to react.createElement, which just returns an object. And React normally just renders that. It knows how to render that object, so it does. So elements are just objects that React knows how to render, and we can prevent them from rendering. I mean, I'm pretty sure that most folks that have used React have like conditionally rendered children. So we know that we can prevent them from rendering. And we can use them to enable certain component APIs because props are public. So going back to the actual example in this page, here we have like a really weird demo of just something that you can do. So we have a component called this, which returns this, the text this, and then whatever the children is. We have a component called that, which does the same thing, but except it prepends that to the children. And then here we have a demo where we are getting a random value and then assigning either this or that to this thing variable, and then actually returning thing as if though it was an element, which it is, because we're essentially just rebinding either this or that to thing. So yeah, something you can do, like conditional components. This is totally valid JavaScript and therefore valid React code. And another thing that we should keep in mind is that props are public. So you can actually take a React element and look at its props. It's not actually against the law. So going back to the column example of this component that takes props, which are column props, and just returns null. Here on line 13, I can actually create one of these elements. So const column will actually be a JSX element. And here I can say, column can have the heading of test and a render function that is this function that just returns like whatever the item is wrapped in a paragraph. And I can console log those props by saying console log column.props, and that will actually print heading test, and then render was going to be whatever that function is. So where we're going with this is that we can have children where we're never actually rendering the children. We're actually just going to be using them to facilitate a certain component API that we might want to do or that we might want to write. And basically using the children and the JSX tags as a container for those props. So yeah, you can do some really weird things with this. So for instance, here we have a terrible, terrible component called stringify child props, which takes a single React child and just stringifies its props. So in the demo here, we're wrapping the thinger component, which we'll talk about in a second, in this stringify child props. And what's interesting here is that this, for one, it will work. It will actually print a stringified JSON object of name of thinger, age 263, and catchphrase is move it bucko. But even though it may look on line 15 like thinger is, a component that's actually mounting, it's not. It's never mounting because it never, like, this element never gets rendered to the screen. We're just using it as a container for its props, which, stringify child props just takes that child and calls JSON stringify on its props. So I'm hoping that this really drives the point home that thinger is illusory. So you can see here that thinger has a use effect, which in theory would get called after thinger mounts, but it will never mount. So this component, like there's no instance of it that's ever created. It never mounts. There's no lifecycle methods, none of that. It's literally just used as a container. Cool. So going back to our table example, let's do a little bit of a walkthrough of how one might implement that sort of table API using some of the mechanisms that we've talked about. But before I go into that, a little bit of a backstory. So a couple of jobs ago, we had a really clunky table component, and in that project we used a ton of tables. There was a whole lot of just fetching data, rendering it to some table. It was an edtech product, and I don't know if maybe that is why we'd use so many tables, but we did. So the problem was that we used a lot of tables and our table component was clunky. And one of the observations that we made is that the overwhelming majority of our tables were just rendering columns. So literally something like this API that we see here on the right would have been very nice. And the solution to that problem was actually creating a table component kind of like this, where we just feed the thing data, give it some columns, and with a render prop, it just generates that thing that that table that we're trying to build. This is an extremely simplified example, but the core idea is there. Side note, one of my favorite ways to approach writing reusable React components is to write the API first. And how I personally landed on this pattern was by deciding that this is how I wanted to use the table component, and then retrofitting things so that it would so that I could actually use this. So yeah, I would recommend honestly to write your component API first. Just if you're building something, pretend like you're using it already, and then put the implementation details in there later. So let's actually look at the implementation of this thing. And for that, we're going to go to Code Sandbox. Cool. So here on the right, we see the actual table that we're rendering. There we go. And let's first look at what's going on, and then let's dive into the actual code. So here in this utils folder, we have this data array, which we're just exporting. Each item in the array is an object with an ID, first name, last name, email, profile pic, basically the same shape that we've been looking at throughout this presentation. So in this main app.tsx, we take that data, we pass it to the table right here, and we then have these columns. So how does the API work? For each column, so on the right you see we have 3 columns of name, email, and profile pic. You define your columns, and then you give them a name, and they take a render function. So because this data, so for instance, let's take the first item and kind of walk through what's happening. So this item has first name Danelle, last name Navarro. This is the fake email and then a fake profile pic. So when the table is creating the actual, output, it's going to take that item and for each column, call the render function and create a table cell. So for the first cell, we're just returning a string of item.last name, item.first name, so Navarro Danelle, and then similar thing for email and profile pic. Sweet. So let's actually look at the table component. Okay, so there will be probably a lot more going on here, but I swear it'll make sense once we are done with this. So first, let's look at the column since, we know that this has been, this is what we expect, right? The column returns null and it has props. So how is this actually working? So a few things are going on. So the table gets children, and the children must be Table.Column elements, because that is what we are enforcing as our component API. And the first thing that we do is coerce those children into an array using React children.toArray. In the case of the table, you could in theory have a table with one column. It probably wouldn't be the most useful table, but it's possible. So we want to ensure that it's going to be an array so we can later map over it. And React children to array is a way to do that. So the first thing we do is turn our children into an array. And now we have an array of React elements that happen to be those column elements that we saw at the bottom of the file. Cool. So then we are going to use those columns to create our table headings. So the first thing we do is we create this name, email, profile pic headings, and we do that by mapping over the columns. Cool. So each item in this columns array is a React element, and we know that that React element has that heading prop and that render prop. And what we can do here is just create a th, since that's going to go in our heading, or in our t head rather, with heading as the content. And then we actually aren't going to use render at all right now, but we're just going to pluck it out so it's not in this rest props, because we could in theory pass more props to the th. Sweet. So now we've essentially mapped these columns into ths of name, email, and profile pic. Sweet. So now let's do a similar thing to our body. So here I'm using use memo, mostly for simplicity's sake, although, probably a good practice to memoize some of this stuff. So we'll do a similar thing where we will take our data and actually map the data into rows. But first, sorry, that was just bouncing around. If there was no data, or if the data.length is 0, we're gonna just quickly here fall back to this no data element, which is right here, just says no data found. So if somebody were to pass an empty array, it would just return that no data found, or whatever the parent decided to pass in as the no data element. That's probably not as important for the purposes of this talk. But then, cool. So if we do have data, how do we generate the rows? So whereas with the headings, we just had to take the individual columns that were the children and map those into ths, here we're actually going to take the data and then map the data into a parent tr, or a table row. So we're going to create a row in the table for each piece of data in the array. And then inside that, we are going to take the columns, which, same thing that we build, or that we use to build the headings. But now we're actually going to use that render function to generate the data for that cell. So thinking about this first item in that data array, we take that item and we create 3 TDs in the TR using the render function that that column provided as a prop. And with that, so we have our headings and we have our body. So we like generated all this markup. And here we can like literally just say the table component returns a table with a T head with a TR of the mapped headings, which is going to be 1 TH for each column. And then the table body is going to be 1 row for each item in the data array with 1 TD for each column for that row. Cool. So this generation of like all this table markup, going back to what we were trying to achieve, can look something like this. And this example is, we're definitely talking about like how to build a table. But the real takeaway I think here is that you don't have to actually render children. These children are never being like rendered to the screen. We're just using them as a container in order to achieve this specific API. And one more thing I want to call out here is this use table utils. So we have this data that is, if you're using TypeScript, this data is inferred to be of type array of objects with, ID that's a number, and then the rest of the properties are strings. And something that's super nice about that is that by creating a utility like this, which, by the way, this utility, all it's really doing is taking that data, like extracting its type, and then returning an object where the table data is that same data. And then this call function knows what the type of each item in the array is. And then we get this super nice utility here, which we can use to type the render function for each column. So for instance, here TypeScript knows that the item is an ID of number, first name string, last name string, email, so on. And if I tried using a property that did not exist, so for instance, pick, it is going to yell at me because that type, or rather that property does not exist on the type. So yeah, with like, patterns like this, you can kind of get like type safety. This is using generics, and honestly, like this actually is more complicated by using this pattern where the column is detached from the table because, normally we'd be able to just use a generic type to infer what the actual props are. But since we've split up the table and the column components, it's hard to tie this data into whatever this column's render function is. But there's ways around that, like by creating utilities. Cool. So this is like a super basic example. And this next one is not exactly like the implementation that we had back where I used to work, but you can kind of like take this idea and like take it even farther and do things where similar to this, where let's see here. So yeah, similar example here, very similar API, except the only thing here is that now some of my columns have this sort property, which is another prop that I'm just, passing to later do something with. And for this table example, you can do something like really easily adding sorting when you click on like a table heading, for instance. And if we go back to the column, still literally just using null. So just abusing the fact that we can look at React element properties and not actually render the children and use components, or rather React elements, just as containers for those props. Cool. So going back to this, some useful utilities that I want to call out is first, there's React Children, which has there's more to this, but some that I find interesting is toArray, which ensures that either one or multiple children will get mapped to, or I guess converted into an array. React Children map will take either one or multiple children and then return whatever you want, or like turn each child into whatever you want per your map function, which is the second argument. And finally, React Clone Element can take a child and you can pass it another like object of additional props to merge into that child. So yeah, when you're doing weird things with React, these methods are pretty useful. So there's more examples. There's other folks that have come to similar to this similar pattern. For instance, this is a thread by a person called Mark Dalgleish, and sorry if I butchered that name, but he's also talking about this pattern. And there's actually, I'm going to link this tweet in the slide deck because there's a lot of folks being like, oh yeah, like this is a similar thing that I do for XYZ library. I think Kent Dodds, which was a recent speaker on the React Denver meetup, recently also like replied to this thread and was like, yeah, like I don't know, I might write about this at some point. So yeah, I feel like I'm calling it illusory children because I think that makes sense. This person is calling it the fake child pattern. I don't think people are using this enough to actually give it like a final name. I'm not advocating that people necessarily use this pattern unless there's a good reason to do so. It definitely complicates things. My personal opinion is that your component API is more important than the implementation details. So if you think, oh, this is kind of dirty, but like, man, it makes for a really clean component API, I don't know. My suggestion would be to just go for it because ultimately that abstraction should be an abstraction. And that is the end of my talk, and I am definitely here for any questions that you all might have. And before I do that, I'm going to switch over to this. So we have one question in the React Denver Discord. How do these null children look like in the component dev tools? So they are not there at all. They aren't rendered. So it's essentially as if though like some other mechanism was creating the markup that is eventually output. But yeah, these things don't mount. For all intents and purposes, they are, again, just containers. Any more questions? Cool. So if not, I thank you for, what is that, a velociraptor? Yeah, so if anybody did have, honestly, like if you have follow-up questions, like join either Denver Devs, React Denver, hit me up. There's in Denver Devs at least, like a JavaScript channel that I troll around in. Also, if you did have, if you experience connection issues, I'm going to get this video over to the React Denver folks, and hopefully they can host it on their YouTube channel. We haven't talked about it yet because it's still, technical difficulties came up, and we haven't talked about the details. So if there was anything that you missed that you want to see again, the video will be available in high fidelity. So, and will this Twitch be saved? Yeah, so it's going to be on the, yeah, if you go to my channel, I think all the videos are saved for like 30 or 60 days or something. But if not there, hopefully we can get the React Denver folks to host this on the React Denver YouTube channel, which has also a bunch of awesome content. Yeah, Kent Dodds was on it recently, I believe, talking about Remix. Absolutely awesome episode. Other folks are giving super interesting talks. I guess one more question. So, in that vein, these components cannot have individual state effects or other hooks. That is correct. They never render. They are like phantom components. So, yeah, they are, I guess, one more time, just containers for props that you will later on use to do something more interesting with. Awesome. Sweet. Cool. It was great talking, nerding out about React. And yeah, go join the React Denver meetup so you can see more events like this in the future. I'm going to sign off. Bye, y'all.